a teacher, you know that today's video is special because I dressed up today and I'm looking cute and it's great. Look at this scarf. It's like a blanket. I've been so warm, so toasty. It's like a little blanket on me. It's great. So anyways, you are about to learn 2 different methods on how to identify scale factor on a graph. And I'm so excited for you because it's going to be great. You're going to learn math. You're going to learn skills. You're going to do all of the things. Have fun with it.
Okay, welcome back to YouTube with Lubelski. We are going to be doing identifying scale factors, and that is sheet 1. It's located at mathworksheetsforkids.com. So go ahead and turn to that so that you can follow along as I do this. I do want to make a quick note though, when we're working with scale factors, one thing that you need to know maybe from previous videos or prior learning with teachers or on your own is that scale factor, S.F, that's shorthand for it, is when we take the new image coordinates and we create the ratio of the new image coordinates over the original. Okay, and this could be doing coordinates or it could be doing side length comparison. You might also see this as the image, which is the new image, over the pre-image, because the pre-image is the original. And so these are some of the words that you might see used to describe, and it's just whatever it is, whether it's coordinates or if it's side lengths, that's what you're going to do is going to create that reduced fraction, that reduced ratio. So taking a look at the directions, it says figure A is a dilated image of. So this is where things get a little bit confusing. You have to really look at the wording for these questions because it says figure A is a dilated image of figure B. That means that B is where I'm starting and A is my new image that I'm creating. It's a dilated image of B. So this is confusing because normally we think of going in alphabetical order, so we would go A to B, but you have to be really careful about how they word it. So the only thing that we want to do is find the scale factor. Now there are a couple of different ways we can do this, and I'm going to show you a couple of different ways. I'm going to show you 1 and 2. I'm going to use the line comparison, so side length comparison, and then 3 and 4 I'll show you how to do it using a coordinate pair of it. And either way is perfectly fine. If you discover some other way, make sure you check with your teacher to see that it will work both ways. So again, I'm going to make sure that I remind myself that scale factor is the new image over the original. So to create this ratio, I'm going to start by looking at B. And B, I'm going to pick a side length. And I'm going to look at a side length that's perfectly horizontal, so left to right, or perfectly vertical up and down. I'm not going to use one of these diagonals because at this point we haven't learned the distance of that diagonal, so I can't really compare those. So you're always looking for side lengths that you can compare that are easy to compare. And so for me, I'm going to pick this side length right here from here to there. And I'm going to count. It's 1, 2, 3 units long. So my new image, my original image is 3 units long. My new image, A, if I look, here's the point. So that's corresponding. So I'm going to count my new image from this line to this line because those are corresponding. This line becomes this one. So we always want to make sure we're using corresponding, the same line, just in the new image. So let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So I'm going to put that into my units, into my ratio right here, 9 over 3. Now, when you're trying to find the scale factor, you want to put it in simplest form. And since the larger number is on top, I'm going to just treat this like a division problem, and I'm going to do 9 divided by 3 gives me a reduced scale factor of 3. That tells me that I have to multiply each side length in figure B by 3 to get the new side length, and we can prove it right here. So in figure B, this side length right here is 2 units long. So I can check this by saying 2 times 3 is 6 units. So my corresponding side in figure A should be 6 units long. Let's count it out. 1, 2, 3, 4, 5, 6. So the rule will apply to all of those. So you should be good. Your scale factor is 3. Let's go ahead and move on to question 2. And we're going to do the same thing, except we run into a little bit of an issue here. So in this particular case, we don't have any lines that are perfectly vertical. These ones are all on the diagonal. So I'm going from, here is A, that's my new image. I'm going from B to A, but all of the lines are diagonal. So there's this really cool trick we can use. By starting at the origin, if possible, I'm going to say, well, how wide is this kite looking shape, this quadrilateral? Well, from the origin to this vertice, it's 2 units. So my scale factor is going to be, remember, it's the new image over the original. The new image is 2 units. So I'm going to put 2 units there for the new one. B is my original, so I'm going to count B. That's from the origin to B's point is 1, 2, 3. So I put 3 as my original. So that tells me that this is a scale factor of 2/3. Now I can check the same thing for the other parts. I can go ahead and I can count from the origin straight down is 3. So I would put 3 on the top. And then from the origin straight down, I go 1, 2, oh, you know what? I messed that up. It was 4 units. See, teachers make mistakes too. So that was 1, 2, 3, 4 units. That tiny little unit was 4 units. And then from the origin down to the point B down here, that's 6. Well, whether you know how to reduce fractions or not in your calculator, you could do the 4 fraction key 6 and reduce it. Or we can just look at it and say divide this by 2, divide the bottom by 2, and we've got 2/3 again. So that proves to me that our scale factor is indeed 2/3 because the pattern carries regardless of what you're comparing, whether it's these line segments or these ones. I'm getting 2/3 is what I'm multiplying by in both situations. So that's a good way to check your answer. And also kind of think about that. We went from B to A and that was a reduction, so your scale factor should be less than 1, which in our case it is. So always check to make sure that it is supposed to be a reduction or enlargement. Okay, moving on to number 3, we're going to do a little bit of a different method here where we're using the coordinates instead of using the side lengths because the coordinates will also be proportional. And so what we're going to do is we're going to look at our 2 images. Remember, we're starting at B and we're turning into A. So I'm going to start by labeling my original image B as A, B, and C. And because a dilation doesn't rotate or reflect or do anything else to the coordinates, that means that in figure A, this one right here is my A prime, here is my B prime, and here is my C prime. So just so I don't forget, scale factor is that new image over the original. And this can even be talking about comparing my new X prime compared to my original X in a coordinate. And I'm going to show you what I mean by that. So looking at A, vertex A, not figure A, looking at vertex A is located at, I have to go left all the way to -20. And then I have to go all the way down to get to A, and that's at -16. So -20, -16, it's like a roadmap to get to A. Then for A prime, I have to go all the way to -15 and then go all the way down to -12. So what did I mean by my X prime compared to my X? Well, in this situation, here is my X, here is my Y. Here is my X prime, here is my Y prime. So I can compare these 2 X values to create my scale factor or find my scale factor. So I'm always going to start with my new image, which is -15, over my original image, which is -20, so x compared to x, the negatives cancel out and I'm left with top and bottom can be divided by 5, so that equals 3/4. Let's also check our y values as well. So same thing, the y prime is negative 12 over negative 16. Top and bottom canceled the negatives, and top and bottom can both be divided by 4. So 12 divided by 4 is 3. 16 divided by 4 is 4. So here we go. We've got our 3/4 as our scale factor, and I can also look at it and say going from B to A is a reduction. So being less than 1 as the scale factor, that does make sense. Another thing you could do is you could also check B compared to B and C compared to C. But if you do the steps correctly, you should get it right the first time by using what I just used. So let's do that with number 4. So number 4, give me a second to clean this up a little bit because I want to make sure I have plenty of space. I'm going to erase some of my work here. Okay, so number 4, I'm going to do the same thing. And I'm going from B to A. So if I look at that, that's going to be an enlargement. So I know my scale factor is going to have to be greater than 1. Seeing that first and knowing that is it also like second way of checking my work when I finish. If it's not greater than 1, then I must have done something wrong. So knowing that fact about enlargements and reductions is a really good way to check yourself as well. So I will say that it'd probably be easiest to compare side lengths like we did in questions 1 and 2. But again, I want to practice that coordinate way of doing it. So we're not going to just do those side lengths. I'm going to just pick an easy one. Here's my corresponding point of my pentagon. So B is my original, so I'm going to label this as A. And then this one's going to be my A prime. And again, I have to write down my coordinates. So my original A is at negative 3, positive, it's hard to read that on my thing. I think that's at 6. So negative 3, 6. And then my A prime is at negative 6, positive 12. So again, it's going to be the new image over the original. So 12 over 6 equals, 12 divided by 6 is 2. And then I can check my other one. Negative 6 over negative 3. Negatives cancel. 6 divided by 3 is 2. So we got the same scale factor regardless. One last check I could do is going back to that method that we used in 1 and 2 is comparing the new image, which is 1, 2, 3, 4, 5, 6, 7, 8 units long, compared to the original, which is 1, 2, 3, 4 units long. And 8 divided by 4 is, of course, 2. So there's our scale factors. I am going to let you give it a shot on 5 and 6. Pause the video, practice those two using whatever method. I can tell you that my method would be comparing the length of this side compared to this side, and the length of this one compared to the length of this one. Because doing the coordinates takes a little extra time to write the coordinates down, but it is a good method if you've got a bunch of diagonals. But the side lengths, if they're perfectly horizontal or perfectly vertical, comparing those side lengths is a great method as well. So pause the video, give this a try. When you unpause the video, that's when I will have the screen up and ready to show you the answers so that you can check your answers versus mine. All right, hopefully you took a second to do 5 and 6 and you're not just copying down the answers to get the work done, and you are actually pushing yourself to try, practice, and succeed with this. So looking at this, you can see that in my work, I compared B became A, and I compared 10 to 6 because it's the new versus the original, which gives me a fraction of 10/6, which reduces to 5/3. You could have also potentially gotten 1 2/3 as the scale factor, which is fine. Don't write it as a decimal though, because if you wrote this as a decimal, 1.6 repeating, you can't really do that in a calculator because at some point you have to round it off. So if it's a repeating decimal, leave it as the improper fraction or the mixed number. Question number 6, we did the same thing. We went from B to A. So my original was 1, 2, 3, 4, 5, 6 units long. And my new one is 12 units. So comparing 6 to 12 reduces to 1/2. You could have done this as a decimal, which would be 0.5 or 5/10. You could have also written this as nothing. That's it. Those are the only two answers you can have. So scale factor is 1/2 for number 6. So if you are following along with me with YouTube Lubelski, you can go ahead and you can push on to do the practice pages that are on your own, sheet 2 and 3. Hopefully this really helps secure that in. Don't hesitate to come back if necessary. And
look, I still look just as cute even after a video gets done. Isn't that great? Oh, look how cute that is. Oh, look at that curl. All right. Oh my gosh, my ear. Look how small my ear is. Do my ears look that small in real life, or is that a filter? Oh, anyways, focus, Lubelski. Do videos for children. Okay, you just learned 2 different methods. So, don't forget, you can compare side lengths if they're on that perfect horizontal, perfect vertical. Compare the side lengths, boom, done. New over original, reduce that ratio, use your calculator, whatever you gotta do. You can also write down A and A prime and compare those coordinates, because coordinates do the same thing. It's like magic. I love math. Oh my gosh, I love math so much. I don't know why I'm talking like this today.